Hello everyone, and welcome to lesson 2.9, which is on dividing fractions. While most of this material was covered in 2.8, I did want to spend a little more time looking at the scenario we were in the last problem of 2.8, which was the word problem. At the very end, we had to convert an improper fraction to a mixed number, so I just wanted to explore that process, how to do it, and go over a few examples to help you out in 2.9. So, to solve or to convert an improper fraction to a mixed number, the first step is we just need to find out how many times the denominator can go into the numerator. We do this to get our whole number because we need to know how many times it can evenly go in, right? So it's closest without going over kind of situation. So we look at that. From there, we take whatever that multiple is, we subtract it off of our numerator to get the leftover piece, and then we write the answer over our denominator. And all three of those steps end up getting us to our mixed number. So let's just take a look at some of these examples here. And how do we handle it and how do we solve it? So our first example is 24 divided by 9, right? So to start out, I need to think about how many times can 9 go into 24 without going over. So I have 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27. Okay, that's too big. So it can go in 2 times without going over. Right? So I know 9 times 2 is 18. That's what I have to subtract off to get my leftover piece, and that ends up getting written over 9. So that simplifies into 24 minus 18 is 6 over 9, which reduces all the way down to 2/3. And I can scroll up a little bit for that. So my answer, that 2 that we found at the beginning, just pulls all the way down. My final answer there is 2 2/3. I found out how many times did 9 go into 24 evenly. It went in 2 times. Subtracted that multiple off of the numerator to get the leftover piece of 6. And then in this case, I had to reduce the fraction down to get 2/3. And that's how I get my mixed number. It's not any more than that. Let's look at number 2. How many times, well, first off, we have 37 divided by 5, or 37/5. To get that into a mixed number, I need to figure out how many times does 5 go into 37. Well, evenly, 5 goes into 37 7 times, because 7 times 5 is 35. I subtract that off, write it over the denominator. So that's going to end up giving me 7 2/5. 2/5 cannot reduce. So that's my final answer. All right, so now we get to a crazier problem. We have a mixed number dividing a mixed number, then we are subtracting a fraction, and then we got dividing another mixed number. So there's a lot going on. Well, as we've covered in sections 2.6 and 2.8, we don't want to do any division and multiplication on mixed numbers. What we want to do is we want to just change everything to improper fractions. So we go through our process of doing that. I'm going to zoom in here just to make that problem a little easier to see. We're going to multiply and add. That gives me 7 over 2. We're going to divide that by, again, multiply and add. 9 times 1 is 9, plus 5 is 14 over 9. And then we are going to subtract 5 over 7. We don't have to do anything to. Divide, and then multiply and add to get 15/14. Now that we have everything into just a fraction form instead of a mixed number form, all we have to do is follow order of operations. We have to do all of our division before we do addition and subtraction. So remember, we have to use our keep, flip, change rule. We keep the first, we flip the second, and we change to multiplication. We do the same thing over here. We keep the first. We flip the second. Change the sign. And we know at the end of the day we're going to subtract those. So we have 9 times 7, which is 63, over 2 times 14, which is 28. We're going to subtract that from 14 times 5, which is 70, and 15 times 7, which is 105. All right, so now we're using all of our skills together. We've converted mixed numbers into improper fractions. We've done our division and done the keep, flip, change. We've simplified. Now we've got to subtract. Remember, when we subtract, we have to find common denominators, which makes the problems really crazy, but that's okay. Remember, when we're finding common denominators, we just multiply the bottoms together. So I multiply the left fraction by 105. We multiply the right fraction by 28. Right. Doing that, I end up getting 105 times 63, which is 6,615. Don't freak out over the large number. Just keep doing your process. Over 105 times 28, which is 2,940. We are going to subtract 70 times 28, which is 1,960, over 105 times 28, which is 2,940. So now, simplifying from here, that just gives me 6,615 minus 1960. All of that is over 2,940. We simplify 6615 minus 1,960 is 4,655 over the same denominator of 2,940. So that's a pretty big answer, right? But we can reduce that if we want, or we can try to change it to a mixed number if we would like. If we want to reduce it, we can. We just need to try to find a number that goes into both. I believe 5 goes into both. Right? So simplifying that, 5 goes into 4655 931 times. 5 goes into 2940 588 times. And that might be the end of it. If we want to change this to a mixed number, because we did have some mixed numbers, maybe you're asked to do that in the problem. We do the same thing. How many times can 588 go into 931? It can only go in one time. So then we subtract 931 minus 588, since it only goes in once. Write that over 588, just like we've done before. And that ends up giving me 1 343 over 588. Now, here's what I'll say about this last problem, right? Things escalated quickly. I understand that. But notice that all of the math that we did, all of the processes that we did, were everything that we have talked about in this unit so far. Right? We converted mixed numbers into improper fractions. Then we divided. Right? We used our keep, flip, change rule to divide. Then we had to subtract, so we had to find common denominators. We used the process for finding common denominators. Sure, the numbers were bigger than what we originally thought or we would like them to be, but that doesn't change what we do or how we do it. Right? So don't get freaked out when you have these large numbers. Don't think that you're doing something wrong, right? Just stick with your process. Everything has an order to how we do it. And if you need to use a calculator to multiply 105 times 63, then do that. That doesn't matter. Not everyone can do that in their head. I wouldn't expect anyone to. So solve that. Then we get these really large numbers, but we know how to subtract because we have common denominators, so we subtract them. And then by subtracting, then we can reduce. We've talked about reducing before. And then this lesson here takes the improper fraction and makes it a mixed number. I'm not saying that the answers are always going to be nice, or it's going to be clean, or they're going to be numbers that are just 2 digits or really small. Sometimes you get some crazy stuff. But if you stick to your process and stick to your guns and do everything like you've always done it, you're going to be okay. But should things not be okay and you have any questions, then feel free to reach out to me. Feel free to email me, because if you let me know, I'll be glad to help. We'll catch you guys later.